myself. It sounded good on paper, but that's the reason why I had to leave. Surrounded by this vapor, I thought it was the air that's hard to breathe. Whoa, I guess I found a reason. Guess I found a reason. Whoa, I guess I found a reason. Guess I found a reason. I guess I found a reason. Guess I found a reason. I guess I found a reason. Guess I found a reason. It probably wasn't worth it. I never knew it'd be the hardest part. But how was I to know that when everything was working at the start? I still remember dancing, but you would always dance 2 steps ahead. They always mention falling. I didn't know I'd fall right through your hands. Whoa, I guess I found a reason. Guess I found a reason. Whoa, I guess I found a reason. Guess I found a reason. I guess I found a reason. Guess I found a reason. Whoa, I guess I found a reason. Guess I found a reason.
I don't wanna care, it's a little unfair that I'll never not care about you. And I don't wanna say, but the second that I wait, no, the words can't get to you. We push and we pull, it's wrong and it's right, it's not black and white. But I know that we'll always be something golden. It's only worth taking to make it. If you took a little time to open up, to see my love, to see my love. It's only worth taking to make it. If you took a little time to open up, to see my love, to see my I don't wanna care, it's a little unfair that you'll never not care for me. I was always scared, no, I couldn't be prepared for you just to be a memory.
He is awake. He is awake. He is awake. And you must worship him. Obviously, I don't mean myself, but instead Enek, right? Who is today, again, watching over us, there, behind all the boxes of Polymaker, while we build a 3D printer. This being the second installment of the series. Maybe first a few amendments for anybody rewatching this, since nobody's here yet. Yeah, last time we managed to go through the kit. We managed to look at the rails, at the extrusions, sort those, discussed a few ins and outs of the Fysetc kit, and yeah, prepared a lot of things, including the heatset inserts for our printed parts. During that time, I babbled like an idiot because I had a audio monitor in my ear that gave me 1 second of delay. So if you want to go back and watch that, please keep that in mind. And let me maybe turn off the sound on my stream monitor, because I'm kind of guessing that you can hear that. There we go. Yeah, so if you go back and watch that, feel free, but please remember there was something going on there. Really sorry, the quality wasn't as good. I added some chapters if you go back and want to look up the specific parts. Sadly, those don't show up in the YouTube timeline just yet, because you need to have a couple more subscribers to actually get to a point where YouTube honors you with some additional tooling. But I guess we can make it work. Yeah, also some amendments. I do know what the difference is between Rails and Extrusions. The difference I had to look up again because I just didn't remember correctly, was the one between the Misumi and the Maker Beam extrusions, where the Misumi extrusions are spec and the Maker Beam extrusions are the ones we have, which means no drop nut inserts for us. So much for that idea. Otherwise, just a note, if you want to catch this stream live at any point in time, 7 p.m. Central Europe, 6 p.m. UK, 1 p.m. East Coast, or 9 a.m. West Coast. I think I kind of screwed that up in my head as well last stream. I also didn't like the way the front cam worked and looked, so some improvements to the stream have been done as well. Mainly, obviously, fixing the sound, making sure that there is less of an idiot babbling, I hope. I got the iPad fixed for camera switching, so that should work better now. And most importantly, that front cam really had to go. So now we have a proper GH5 there that will hopefully give us a better picture. It's 4K. We're still streaming in HD quality, so who knows? We'll see. We'll see. Yeah. Also, concerning the build, I told you last time that we will be building mostly stock, and then I showed you this. The reason why we're going to use this directly is mainly because I don't want to waste the filament. I think it's very important to always keep in mind the environment and reduce, reuse, recycle. If we can not print a couple parts and directly move to this, I think that's a good idea. So we're going to do that. Other parts we will still try to do as stock as possible. Obviously, with the PCB inserts, we barely have a choice there as well, as our extrusions aren't stock anyway. Yeah, that's mostly it for the introductions. The plan for today is continuing, obviously, mounting the rails to the extrusions, squaring the frame, setting everything up. Let me maybe see if I can get that monitor out of the way a bit. There we go. That's better. Yeah. We'll see how far we get. I kind of hope that we can get to a point where we already have an entry point to electronics and wiring next time. We'll have to see if that is manageable or not. Oh, yeah. That's it for the intro. Let's get into it. Obviously, need to maybe clean up here a bit. And I think I still need to have a word with that iPad because it went into sleep mode again, which it shouldn't have. Give me a sec. This is not workable. Should be an easy fix. And by the way, I will be adding chapters to this video as well. If you want to look something up, if you want to skip the intros, always look for those. Even if they don't show up in the timeline, they are in the video itself. So yeah, no need to listen to me babble about things you're not interested in. Would be nice if somebody showed up at some point. That would be exciting. Yeah, but in general, I guess we're gonna leave it like that. Just need to remember to use my thumb a bit more. Yeah, moving on. Let's see what we can do here. Moving to the top cam, because obviously first we need to now look at our extrusions. If you remember, last time we already sorted them. We already marked them to where they need to go, so we have a good idea of where we need those. This time it's a question of then screwing them down to the rails. Wow, this there we go. So extrusions, let's move the keyboard out of the way and let's grab us some shiny rails. We already got those earmarked for the different parts as well. And this one. Well, I guess this tape is quite adhesive if you leave it for a week. Yeah. And obviously we need the manual here. You're already seeing it. Now I can see it too. And this is the part where we get started. In the manual you see the no drop nut inserts, and you're asked to insert M2 hex nuts. We have these provided by Fysetc. Oh, and I know why. I know why we're going into low power mode. Haha. This should solve it, hopefully. Yeah, so we're using these. These are notorious for stripping. So the thing we are going to do is, first of all, we're going to use Loctite. I have Loctite Blue here, which is, or like a variant of Loctite Blue, which is meant to securely hold a screw very firmly. But if you apply enough torque, you can actually loosen them. I think that's exactly what we want in this case. We want those screws to be in here, even though we can't torque them down too much, and we still want them to sit firmly in there and not rattle loose. We're also going to use each and every single hole here instead of just every second hole as the manual instructs here, just to give us a bit of a better grip on the whole thing. This will mean that our X gantry, the Y gantry, that doesn't matter in terms of weight, but the X axis will gain some weight, but I think that's marginally important, so we're just gonna ignore it. Yeah, so that's how we're gonna do that. Obviously, we need some screws as well, so let's grab our bag of screws and let's see what we have here. These are Extrusions, so I guess we have two here. Extrusions are the ones with only one hole. If I can trust my marking skills, we're going to take the side opposite of the sticker to slide those in, and we are going to apply the Loctite not to the screw but to the insert, just because I don't want to risk getting any Loctite on the rail when we screw down the rail to the extrusion. So yeah, that's the plan here, and I hope there's still some in this bottle. That's way too much, damn it. I'll have to wipe that down. Usually you can just have a bubble form on the tip of the bottle opening, but that obviously only works for the screws and not for the inserts. Also, the reason why we need to be a bit careful with the amount we're using here is because we do not want to intentionally or unintentionally distribute this in a way where this comes anywhere close to the ABS. So basically all our printed parts, and yeah, that's why we need to be a bit careful here, which obviously I wasn't. So next one, we need 4 in total right now. And there we go again with the excessive amounts. That's way too much. Well, we'll make it work. We'll make it work. As long as some lands inside the hole to then grab our screw, I guess we're fine. Just need to make sure that we don't spill any anywhere. Cool. As we can see, we're supposed to slide the inserts in a direction where they face the hole. So that away, and the other one as well. And the way these need to go in is with the, you can see that they have a long side here and a short side here. Maybe let me show you this here, right? They have a shorter side and a longer side. And this longer side is actually, if you have two of those, it's actually exactly the length of a of the distance between two rail holes. So should fit pretty well. There you go. And we're supposed to then grab ourselves, in this case, this is a Z extrusion. And let me maybe grab some more shop towels here. Give me a sec. Now get these back into my ears. That's always fun. There we go. Yeah, and we're supposed to make sure that that hole is still visible, and we actually get a distance that we need to adhere to. So we're going to need some let's do it with a manual. Some way of measuring some distances. And we are supposed to find ourselves M2x6 socket heads. Let's see where those are. M3x8 button heads, we have enough. And here are our M2x6 socket heads. If we run out, we run out. I think I have a few more here. And let's see if these fit. Yes, they do. So, 2x6, we need this one, yeah. And we're doing these by hand. So you may have seen that I have a couple of electric screwdrivers here, around here, each with a different bit in it. But because these inserts are so fragile, I would rather do those by hand. We're also not going to completely tighten these, because it's really important that these get tightened from the middle to the outside and not any other way. So you don't have any unintended forces that may potentially bow your extrusions. Or rather, well, actually, that's a good question. Maybe anyone, maybe somebody can tell me this in the comments, since no one's here yet. Damn you! No, I'm kidding. But I'd be very interested in where the majority of the force is. Then we're going to Move this here. Just hand tight, so as soon as it touches, and then quarter of a turn back, so we can still move those. Yeah, let's see if this Locktite trick works out, because obviously I'm doing this for the first time. I'll let you know. In general, I would say don't apply any force here. That may be rather important, because these are probably very, very sensitive to any kind of force. The problem we're going to run into right now is that we can screw down the points where our carriage stops sit. So you may be noticing that I can't actually put this stop back in once there's a screw in there. So I'm tempted to instead just leave 2 screws out. And see where that leaves us. Now this is still not movable. There we go. Now we can slide that back and forth. And obviously now we need to be a bit careful. Put back our stops here. We can still add the screws in later once we have the end stops or the slide off protectors mounted either side. Still a possibility. Not sure if we need to. I think this should be rather stable. Yeah, so second one. Again, we still need a hole to be visible, and we obviously need to still prepare some inserts here. There we go. And this is almost empty, I guess. Yeah, I'm kind of hoping that this Locktite trick will allow me to build a more stable printer. That then hopefully performs a bit better. Although we're not looking for all that much speed here, or I already hinted at that during the last stream. This is going to be mostly printing nylon, because especially PA12 nylon I really like. It is still very temperature stable. It is by far not as hygroscopic as PA6. which yeah, you just can't store for can't store anywhere. Yeah, and also nylon, as far as I am aware, is one of the few plastics that are actually indefinitely, or at least very long, recyclable. That's something I will definitely need to look into. Is recycling, how that needs to be done, what I can do. If you're 3D printing and you have an interest in doing this as, I'd say, ecologically well as possible, then yeah, try printing in things that are actually recyclable. By the way, ABS being one of them, nylon as far as I know the other. I also know that where I am living, we are asked to specifically recycle CDs separately. So I'm assuming that polycarbonate has a very good way of being reused as well. Just an assumption, so you know how it is. I may be talking completely out of my ass here, but yeah, that's at least my assumption. So these are the materials I actually want to be printing. With nylon, I have had very good success. I hinted at that in the last stream. I actually built a pick and place machine that needs a rebuild, and for that pick and place machine I printed all the parts in nylon. This, for example, being one of them, where this being supposed to be an auto feeder, where you can feed components to a dual nozzle head for pickup. These printed very well. I see literally no creep at all on these parts because they're PA12 and not PA6. PA12 having way less issues with creep, and yeah. There are a couple things that need to be reprinted though, so yeah, that's kind of the plan. To reprint those and then to figure out how to recycle parts we no longer need. It's going to be exciting. Not sure how yet. The major challenge is to even find a location where I can do that, because space here is somewhat limited. And yeah, not sure if we can do that anywhere else. I might need a proper workshop. Ooh. That would be awesome, by the way. All right. Almost got all of these in. Then I guess I need to locate those guides to center the rails, and we need to move them into position. Ooh, and I am a complete idiot. Because while I meant to screw down another Z or Z rail, I actually grabbed one for that we designated for Y last week. That of course can't stand, so I guess we need to take that off. There we go. And I think I have 2 more here. By the way, another potential amendment to last week. I mentioned that I think when greasing or re-greasing your rails, first of all, check if that's even necessary. I hear that the rails from LDO come pre-greased with a workable solution. So don't go re-greasing those. If you don't, well, if you don't specifically want to participate in speedboat challenges and require your printer to be exactly the way you need it, and I'm kind of assuming very few people will still do that. But one consideration should be where you are, how humid the environment is where your printer will need to work. Because if you really only grease the rails and don't protect them afterwards with rust preventative, you may get a rather nasty surprise with your rails rusting. Obviously, rust preventative would collect dust and abrasive particles again. So there is a bit of a trade-off here to be had, and I would actually think that it should depend on where you are in the world, how humid it is, how even how far away you are from the sea, from oceans, from salt waters, from saltwater air, right? That should make a difference in how you need to protect your rails. So yeah, just check that, make sure that you don't risk your rails rusting. That would be very unfortunate. I still think that at that point I would rather use a proper rust preventative than rely on the grease that is probably far more sticky to protect my rails. So the right tool for the job. Okay, we can still move that back and forth. That's very nice. Did we? Yes, we also put both in correctly. Let's see here. What's the next step? Oh yeah, we need to find our guides. You will notice that I printed some parts here, even though you usually print parts in either your primary or your accent color. I printed a few parts here in black. Funnily enough, I didn't print those for this build, or at least not all of them. And for the other build, I actually decided to print these in black because they are hidden in the electronics compartment. And the other build is using Polymaker Pop Blue and Pop Purple. That's going to be our salad fork. The problem here being that while I love my Polymaker, they actually don't ship those to Europe yet. So I had to order them from Amazon.com for an arm and a leg because it obviously had to be these colors. There was just no getting around that fact. So yeah, had to be those, needed to be done. There was no getting around it. But obviously then I will not at the same time print all the parts in those colors, because it was stupid expensive, to be honest. What do you do? What do you do? I wish those were available here as well. So Polymaker, if you ever see this video, please, please, please get us the pop colors and the glow in the dark colors as well, if you can, in Europe. Because I would have loved to print this printer in glow in the dark, or at least partially. That would have been amazing, I think. Yeah. All right. Whoops. I think we need to... Yeah. These are actually the Y rails. What we're gonna do here is we're just gonna slide these out outright. Prepare another set. No problem at all. No need to loosen the rails, I realize. If you can read, that helps. Also, we wouldn't have had to remove the other rail because we already grabbed a Y rail there. Well, I guess somebody's still slightly nervous here. And with that, obviously, I again mean Enek. It's definitely not me. Definitely not me. I'm completely used to building 3D printers on the internet for everybody to see my screw ups. No problem whatsoever. And if you find sarcasm, feel free to keep it. It's free. Though, as with all the things that are free, if it's free, you're the product. Ponder that for a while. There we go. Yeah, I think that was one. 1, 2, 3, 4. Yeah. There we go. And then let's do this again. E-extrusion. 1, 2. And another set. Interestingly enough, these will be the last ones we will need, I guess, in the long run. But we're obviously not going to use the CNC gantry for the first time. So it's actually amazing that while Fysetc already packaged that that CNC gantry. They still give us the inserts to go without it and the extrusions, and they even would allow us to build the stock Voron bed. Again, not gonna do that. It's just a pure waste of filament to go there first. We already know that for upgrading that. With the X-Rail, that's a bit different. Mainly because A, we already printed those parts, and B, because it's additional parts you print, not parts you then leave out. Yeah. I guess the Z-Rail is gonna be fast then, since we already did this. There. And that should do it. There. ZZ Y is here, and another Y rail is here. Let's move that to the center. Move these to the center as well. Now we're gonna do this again. We're gonna grab us some screws here. There we go. There we go. I kind of wish I could use an electric screwdriver here, because this is somewhat tedious, but specifically with those inserts, I don't think it's a good idea. So there's another v0.2. Looks like we might have just enough 2x6 to also make the X-rail happen. So there. Now the manual asks us to obviously center our rail and then leave some space at the bottom. The manual also warns us to make sure we don't lose our rails here. We do still have the stops in place, so I think we're good. We can put in the final screws later. We're supposed to set the distance to 38 centimeters. Well, just about. And that distance is meant to be from the end where the hole is. So what we basically can do now is we can use our end as a registering surface. Move this there. And I should have used the other hand. But we can push this in as far as we can. And then screw that down. Again, I'm not exerting too much force on these. We just want it to sit somewhat fixed in place. We still want to move things around a bit because obviously we need to at the same time make sure that we center our rail here. And what I tend to do is, once I think I have my rail centered, I'm actually exchanging the guides real quick to make sure that they're both still even, which at the same time gives me a chance to check those guides. I slightly tighten the front and the back because, again, we now need to tighten the screws from the inside out. Actually, we can probably also do it directly that way. So making sure that we have 38 centimeters there. Slightly tighten that one. Slightly tighten that one. Flip those. Just to make sure that we don't have any inconsistencies. Now we can actually tighten these some more. There we go. That felt really, really good. I should also be able to tighten that down now. And obviously the other one as well. Now we should loosen these again, so we can de-stress the situation a bit if we have stresses, because now our rails should sit fixed on both extrusions. And then we want to tighten them inside out, one at a time, alternating. In this case, I feel like as soon as they hit, it's not even a quarter turn anymore before they really seat it. I can totally feel how you could strip those. I feel some give in those threads already when I turn those. So be very careful when you do this. I hope I don't need to undo these because I screwed something else up, because I really wouldn't want to do this again. At least not for now. We may at some point need to re-loop those, but I guess I could then just keep the rails on the extrusions and just take the carriage off. Might be an interesting experience. Probably not the best idea. There we go. Take the guide off. Nice. Ooh, and I forgot a screw. How dare I? There we go. And I guess these are pretty much perfect. Wow. That worked out better than I thought. This was by far not as frustrating an experience as I was expecting from those inserts. Pretty satisfied with these. Moving on. This took ages now already, so let's hope that we can gain some speed here now. We're now asked to let me show you the manual here. We're now asked to add the rail stop on one side. Thinking where? So here's an interesting conundrum. The manual explicitly tells us that it won't call out Oh, okay, so they ask us to insert the nuts here. And again, I'm not sure if those carriers will actually fit there. Let's try it out. We do have those in the other box. Damn it. Give me a sec. Because obviously, to make our life easier looking for our Legos, I split them up into bags. I know why Lego is doing it. Doesn't mean I need to like it, but the question is, where did I put those? It's still be here. But I don't think they are. I hope I didn't put those in the recycling bag already. Because to get back to the topic, if you actually plan on recycling your filament or any parts of your filament, the most difficult part, I guess, is keeping it clean. And to keep your filament clean, the best way of doing so would very likely be if you moved your, let's say you have fail prints, if you move them into a specific bag by filament. And if you sort that by filament and by color, you may even be able to reuse some of, or a good chunk of it. That may be the actual ticket to success in that case. And I'm going nuts. I guess we don't have a carrier here. That's a good question. Did we have a carrier here? So in general, the manual asks us here to provide some way of screwing in those rail ends. Which obviously we want to do. The no drop nut inserts, they tell us, are optional. The question now becomes, do we use square nuts or hex nuts? Funnily enough, I do have some square nuts. But I don't think we need them. I don't think we need them. Oh, this should be relatively easy. Let's just grab a hex nut. This looks reasonably easy. We can already pre-screw that and just slide that into the rail then. I don't think we need to print one. That should still be fine. The question here would be, where the hell, or where of Fysetc did you put? I found my nuts. Nice. That's nuts. And then obviously we can remove our mess here. Before we mix those up. And grab 2 of those, and we need M3x8s and 3x10s. It has to be a big bag. Where is the big bag with the M3x8s? Let's take that one. It tried to escape, but we found it. So, there we go. And then we need to put that aside. Find our rail ends. Oh, and I'm going to move the Loctite aside here a bit so it doesn't come in contact with any plastic parts. That would be bad. Then we need to find our end stops. Ooh, and I just remembered something that we need to do as well. That's something we need to kick off in a moment. Is we need to print something. Because I looked at the instructions and I noticed that Fysetc wants us to more or less use a Wago holder and this connector we saw in the last video to connect the bed. I'm not that much of a fan of Wagos if they don't actually have a purpose, like let's say provide quick connects. And I don't necessarily think that a 12 by 12 centimeter bed qualifies as something you need to quick connect. The problem with that is that all the cables are too short if we don't want to go for Wagos, which means we would need to solder them, which means since they potentially are part of a moving piece, that's not as much of a good idea. So we need to actually right now kick off the print for the Wagos. So let's go to our slicer real quick. There we go. I actually already prepared this. I just didn't have a chance to properly kick it off yet. So we're going to turn on our printer. And we are going to go to our slicer. I hope that the printer is going to boot properly, because that one specifically I haven't used in a while. Oh, that looks good. Let me quickly turn on the filtering inside the printer, because that's at the moment done by 2 Elegoo filters that you'd usually use for a resin printer. Just put it in there. I mean, I really don't need the full Z height, and those 2 things can just live in there, filter the air, move it around a bit, because I haven't had the time to actually go in the printer and switch the voltage for the fans in the Nevermore to 12 volt, which I have to do if the new fans in those in the Nevermore are supposed to run properly. Also, I improved the wiring a bit, and I do want to do some of that stuff on stream. So it's coming up. For the moment, we need to deal with the filtering as it is, which means that those 2 Elegoo things need to do their job. Oh no, it's actually Enek cubics, not Elegoos. I really don't have it with company names these days. By the way, something I noticed in the 3D printing community, many people seem to be giving specific companies way too much credit. Be that evangelists and fanboys for Bamboo, be that people who prefer high wind rails. I don't mind if you really like that stuff. You really like that stuff, but keep in mind, those are companies. Those are companies that want to make a profit. They're not your friends, and either their products are exactly what you need, or you need to make sure that your interests are very well protected and accounted for. There's no reason in the world that should at least let you go fanboy and not exactly look at your interest. Ow. Okay. I really did not do that. Fuck. No. Some concentration would be nice right now, because I just noticed that while we obviously have this hole in the right spot, this hole isn't. That's kind of unfortunate, because that means we need to A, remove this Endstop and move it to the rail end, and move that to the other side later. But B, we need to also take our perfectly measured 38 millimeters. And apply them to the other side. Which means, at least on one side, loosening those threaded inserts, those threaded rail holders here. That sucks. I was pretty happy with how that turned out. But I guess that is building a printer. Might need to read that manual more carefully, or look at my work more carefully. damn. And here I was so happy with what I had. Not too much of an issue though. I mean, it's a really quick fix. We still have that set up here. Oh, push that in. Push that in there. Use our guides. Screw down the middle one. Screw down the middle screw. Other side as well. And look at that. Now they're correct. Let's check this real quick. That works quite well. So let's screw those down. By the way, in case anybody wants to know what kind of screwdriver this is, because I know people tend to get interested in this stuff. I actually haven't found a place where you can buy this. This was part of the Snapmaker A250T that I bought a while back, that we're going to use to do PCBs, because that's the whole plan, is design PCBs, print enclosures, print prototypes, mill PCBs, use the laser to then laser away a pre-applied set of masks, so we get our PCB mask. And here's a question though. If this fits, then I think somebody really needs to concentrate some more. We'll get there. We'll get there. Nobody's perfect. Please always keep that in mind, especially with what I'm doing here. I may come over very convincing and may state things in a way that makes you think, yeah, he might be right. I might not be. At the end of the day, always do your own research in anything, in politics, in any opinion you may have. This thing with the companies, right? Do your own research. What can you expect from that company? What can you expect from a politician? What should you consider when constructing or voicing an opinion? Right? There's a lot of things happening in politics right now that you may have an opinion on. We will not discuss them on this channel in any way, but do your research. There are quite significant things to consider when voicing an opinion. You may not be thinking of everything, so also keep an open mind. Try to ask questions. All right. That looks good. That looks really, really good. Let's get that stop in there. And I just realized that you can't properly see that, see what I'm doing, because we still have the printer booting up. Let's see what we can do here. I think I need to close Orca Slicer real quick here and restart that. Yes, please save that. I don't want to do that again. Orca Slicer has been pretty good for me. I like the interface, I like how it behaves, but I think my 3D printer is actually not connecting to the network, so interesting. Let me check that real quick. Yeah, that looks like we may have a problem here. This is the general problem I am having at the moment, because my Wi-Fi is just full and overloaded, I guess. You wouldn't guess it, but if you do in any way have a smart home application, most of those devices nowadays actually use Wi-Fi. And if you then build your own routers, which I do, and you use one of the recent chipsets from Intel to do so, the AX200, AX201, those chipsets are actually very, very finicky when it comes to allowing you to run your system in access point mode. So yeah, might not be a good idea. Let me see here. The question would be, what's the Wi-Fi password? And I guess you'd want to know as well. So let me see if I can do this without showing you. I think I know. I think I know. Let's see if this works. Because obviously it has been some time since I set this up. And I really don't want to restart my router, because that would mean that we lose the connection to the stream. That would suck. The other option would be to run a cable, I guess. But obviously I don't want to do that either. Let me see here. Maybe I can make this happen without you necessarily seeing anything. not really experienced in this stuff. Oh, I know. Give me a sec here. Let's try this again. This is unfortunate because I was hoping we could get to the bed still. And this being at least an 18-minute sprint, if I remember correctly. It would be nice if we could get that printer working. Oh, look at that, look at that. I think we may have a winner here. Nice. That worked. So, moving on. See if we can make Orca Slicer access that now and print. There we go. I may need to find out what the IP is though. Again, sorry. Where the hell do I find the IP of this device? That would be interesting. That would be very, very well, very good to know. Because I do see the network, I do see the network device, but Clipper screen does not show me the IP. And I wish it did. System input, Clipper screen. Yeah, let me know in the comments where I should have looked. I guess I am just going to ask my server then where that printer is supposed to be. for the first attempt. Let's just close Orca and start it again. Maybe it just had problems. Let's access Enek. There we go. Oh, look at that. Turning it off and on again. Should have known. Should have known. IP didn't change. This, by the way, being the Trident, what you can see there is the camera in the front. That camera sadly only has a frame rate of, I guess, about 6 to 7 frames right now. Well, at this point in time, actually only 4 to 5. Interestingly enough, that's a result of me fiddling with the configuration. I had the camera is a StreamCam, I think 980. So really good 4K camera, absolutely nice with focus settings and everything that you at the moment can see here, obviously because something screwed the settings. And that let's upload and print that. Yeah, that is connected at the moment to the USB-C port of the Raspberry Pi 4, which I was kind of hoping would get us better performance than the USB 3 ports on the back. Spoilers, it doesn't. The reason why I attempted this in the first place was because I was only getting I think 10 to 12 frames a second from one of the USB 3 ports. Yeah, you see how that turned out, so don't go down that route. The only reason why it's still in place is because obviously it's really hard to get to those electronics. And I know some of you may now think, hey, why didn't you do the reverse electronics mod? Why did you not make it so you can fiddle with the electronics from where your printer is standing? Fair point. I don't think it is better to fiddle around inside that printer and try to get access to those cables. And I have some concerns about if you're opening and closing that lid a lot of the time, and if the cable guides then like get pinched, or the cables itself get pinched by that lid that's polycarbonate or like plexiglass or whatever you have there. I'm not sure if that's going to be good for the cables and for the stability of the installation. So from what I saw from the reverse electronics mod, I'd have some concerns there. And for the few times that you actually access those electronics, which we will do at least on 2 occasions coming up, or going forward, I still think it's not warranted to have that reverse electronics mod. I'd rather take the printer off its current location and just move it to there. By the way, you can also see the snap maker that's directly adjacent to the printer through the glass. Obviously, none of these are particularly well set up, and it's kind of milky, but we can still see what's going on. This printer, by the way, is going to need quite a bit of preload or preheating here. And I will actually cancel this print real quick, because I want to, oh no. I want to modify the auto Z offset before we print, because I have been having too much squish. Not sure where I put that macro though. It's been a while. Printer, tools. Oh, that's the tool heads. By the way, one of the ways I organize this is I have tools. Those are the tool heads I'm using specifically, or the RCF or ERC, depending on how you want to call it. Obviously, we have clicky here, but I don't think the setting was there. Let's look in the printer config. Might have been here. Really good values, by the way. So quite satisfied. Again, the bed mesh on this machine I talked about last time. The bed mesh on this is a bit, how are you doing? But I guess it's fine. Let's restart the firmware here real quick so we don't forget, and let's load this real quick so you get a bit of an idea. This is the bed mesh, and I realized that we can still move the front left corner up a bit and the front right corner up a bit, but this is basically what we're working with, and that's fine. But am I especially excited about how those rails and extrusions turned out? Nah, I guess not. Maybe something we can exchange later. Okay, that was quite the squirrel. Let's maybe look at the actual thing we wanted to look at. And I think the setting we were looking for, by the way, the printer being called Thor because I call all my network devices something from Norse mythology. This does not have anything to do with Marvel, although if you like it to be Marvel, then feel free to just... There we go. That's the one I was looking for. I guess we can actually go stock 0.5 here. Wait, did I? Yeah. And we saved and restarted. And let's look at our dashboard. We're initialized, and let's try this again. Let's try this again. There. So about 18 minutes. I think we can get there in 18 minutes, or at least we will have a print that's going to finish faster, although it's likely also going to preheat for about 20 minutes or so. That's something I have dynamically set up based on the temperature it already has. but I'm pretty sure it will finish before we get through the another 2 hours of the stream. That seems to be not very interesting to anybody because I'm still not seeing anybody in chat. Dang. Well, you'll regret not being here at some point. You could have been one of the first people I get into really good conversations with. Just geek out. That's why I'm here. That's why I'm doing this. So yeah, feel free to join anytime you want. Again, streams are going to be Saturdays, 7 p.m. Central Europe, 6 p.m. UK, 1 p.m. East Coast, 9 a.m. West Coast. All right, moving on. Let's build a printer now. Let's really go build a printer now. We did that. Now we're getting somewhere, because now we need our C extrusions. Or those. Good thing we marked those. Those have 2 holes in the end. Just for reference. There you go. 2 holes in the end, supposedly, and no holes otherwise, if I did this correctly. And that is also shown here in the manual. Now we're supposed to slide in our rails exactly where those holes are, which we're gonna do on the backside, obviously, because we still want to keep our labeling for a moment. There we go. And get the second insert in there as well. Nice, that was kind of painless. We're kind of getting asked whether we want to, or whether we are want to consider having the nuts up or nuts down, meaning that obviously you have 2 orientations for those nut carriers. In our case, I think we're good. I think we're good. We only have these. And funnily enough, I always would put those with the closed off side down, obviously. Not just because it's closed off, but also because you have way more area contacting your extrusion if you do it this way. If you use the other side, you only have, like, these are slightly offset here, if you can see that. Right, so they protrude past the PCB, and if we do it this way around, then we only have very small parts here touching the extrusion and tightening against it that might cause some additional problems. Potentially. More contact, more better, I would say. But the orientation here doesn't necessarily impact us. We do need our 2x6s again. I can move these aside for now. Oh no, we don't need M2 because we already did those. What we need to do now is we need our center guides again, and we need to position our rails on our extrusions well, while having a 33mm distance from the top. Now, since we did that wrong just now, it would be nice to consider what the top and the bottom is. The funny thing in this case is that those C extrusions are just about the same from the top and the bottom. So this is Paul safe. I can't actually screw this up. Thank you, Voron team. This is how things should be, right? Always account for me not reading your manual while following your manual to build. That's a very, very important consideration that you should always keep in mind. 33mm. Perfect. To the dot. There we go. That's on there. That's on there as well. Let's do the other one before we start screwing around here. And I guess you actually want to see something. So look at that. 33mm. Perfect fit. Let's do this one. And yeah. There we go. That should do that. Obviously, we need to use our rail guides to. Let's do that again. Let's do that again, just to be sure. Let's push this all the way in here. Rail centered. There we go. Awesome. Now we can tighten that as well. Again, switch those out just to see where we're at. Yeah, that should be fine. I guess we can tighten these down. Now, again, ooh, that one definitely didn't feel good. Although that feeling could have been the Locktite, because it will already, like we did these way at the beginning, and the Locktite will already have somewhat cured. All in all, it takes about 24 hours for the stuff to cure fully, but initial curing already sets in quite soon. So yeah, if you want to make changes to something you applied Locktite to, first 24 hours. That's also the time when you potentially don't need to reapply it. Anytime later, you may want to. So here's an interesting tidbit as well. Oh no. All right, it's just the mark for the screws. So I guess we're good. Obviously, again, if you're using Locktite to secure your rails, especially with these inserts here that you can't necessarily tighten down fully, or at least not as much as you want. Make sure you don't touch the wires. That would be bad. And I guess Enek doesn't want to show himself today. Again. He's very comfortably sleeping in his bed that does not get covered by a camera. But yeah, best dog in the world. Best dog in the world. Somebody joins. Maybe we can have a play with Enek. Until that's the case, I am just going to build a 3D printer. You wanted it that way. It's all your fault. No. Well, to some extent it's mine, because there are people that would join, but they have very little to do with 3D printers, so they would do that as a favor to me. And while I do appreciate the thought, I can definitely see them having better things to do. One thing that we may need to be careful with is leaving these in there, at least for now. Like I said, we may put in screws where those stops are later. Cool. Oh, and we get to put in ends again. Nice. I like those. I really like those. But where the hell? Oh yeah. Damn frickin' GoPro. Yeah, okay. That I wanted to show you another angle, but I guess you're going to have to be content with this one. There's another one. And here as well. I love this color, I can tell you. This color is awesome. Interestingly enough, I first considered to use the ABS, but I am very glad I went with the ASA instead, because the ABS looked less bright, and the slight difference in how that looked kind of seemed important to me, because I wanted it to be really, really punchy yellow. I think that just fits better with our teal parts. Just saying. Not that I have any idea about colors, right? Again, game developer. Actually, programmer. We are expressly forbidden from doing graphics, because you can always tell when a coder did graphics for a game. It never turns out well. That's, by the way, also why, at least in the last big company I worked for, coders were allowed to do placeholders, but they had to be Chuck Norris. Fun all around. Nobody ever said that game developers don't have a sense of humor. So also we can take these off now. And by the way, we can also take these off, because we have stops now. And we can then grab ourselves another for these. To just really screw down this rail. Why? Because we can. And because somebody would have to explain to me why this is a bad idea. Apart from wasting maybe a dozen screws on something that doesn't make a difference. But who knows? Who knows? Maybe we can take a couple of those out later and see if it actually makes a difference or not. You never know. You never know until you try. Would be kind of interesting to do that test, but also guessing that the empirical data on that may be hard to come by. All right, cool. Really happy with this. Moving on. Oh yeah, we get to do blind joints now. Nice. So top and bottom extrusions. B. B extrusions. So these are meant to have two M3 nuts preloaded and then M3x6s and M3x10s in the end. That's easy enough, I think. No, these are flatheads. M330s. M3x6s we have here. Let's put the M2x6s aside. And the M3x10s, those are T-nuts for whatever reason. There we go. We need 4 M3x10s. Yeah, I think I'm just going to continue until I have at least a large part of that printer built now. There we go. Those are in. These we don't need. Now the 6s. 4. And then we need another 4 nuts. That's nuts. And since these do not have any holes or any distinguishable marks, I think we are just going to insert them here on the top. That way we can still keep our sticker on there for a bit longer, and I don't need to deal with removing the adhesive just yet. There we go. Yeah, still like the way this is set up, by the way. Standing desk definitely has its advantages. All right, and we're asked to orient our assembly. This with the screws to the front. I'm assuming that's the same with the upper part as well. Let's put that to the side for now. Let me actually show you the manual, and let's move this stuff to this side here. So this oriented to the front, this also oriented to the front. One of my nuts fell out. Probably not healthy to just have your nuts drop. And then, ooh, our printer is going burr. Let's maybe have a quick look at what that's doing. That printer, by the way, has been ballers reliable. It's like that's the printer that basically printed all the V0 parts in 2 plates. Just 2 plates, including the Nevermore, including everything else we need. 2 plates and go. It was, well, did it? Might have been 3. So 2 teal and one yellow, but the core parts, 2 plates, and that was it. And it printed all the parts for the salad fork in just about 1 go. So really, from a reliability point of view, as soon as I exchanged those Fysetc fans, perfect. All right, moving on here. Getting squirrel again. I will leave the manual for you guys. I will have a bit of an eye on the printer. Well, actually, you can help me have an eye on the printer real quick. And that way I can go and have a look at the manual. It's, by the way, currently doing the auto Z calibration. That has worked out really well for me. You can see it is using Clicky, and it's been awesome so far. Reason why I'm using Clicky, by the way, is because I do not trust tap with glass and diamond back nozzles. I think that's a very bad idea for a lot of headaches. So I stuck with Clicky. I made sure that that setup is as solid as it can be. If you don't have that concern, I would always suggest going with tap, but especially if I'm printing nylon, and as I already showed you, I like my nylon. Yeah, it's always gonna be glass. I don't like printing nylon on anything else. Read the next 4 pages before continuing. So interesting. The manual tells us, hey, for consistency, we will keep this upright, but feel free to lay the assembly flat. That makes sense. That makes sense, because now we need to basically take these and get them on there somehow. I don't think it would be a good idea to do this standing up, especially since we want them to be square, which also involves a couple of these. I guess. And I guess it's also a good idea to get our clamps ready. Let's see how that printer is doing. Look at that. That is so awesome. It just does it. It just does it. I am so proud of you, little Thor. You're doing well. You're honoring your name. By the way, if you have suggestions for the salad fork or the V0 on what the name should be, put it in the comments. Remember, it needs to be from Norse mythology. Hail, Heimdall, Thor, Tyr, Yggdrasil are already taken. But yeah, feel free. Feel free. Let me know in the comments. Very interested to see what you guys come up with. This looks like a very solid print that's going to happen there. So I guess we can just stick to the manual and see what the printer came up with once it's finished. We don't have any need to print anything else right now, so I guess we're good. Yeah. So we laid our assembly flat on the ground. We are asked to do, well, basically blind joints. That's why we inserted those or preloaded those nuts. We're also asked to preload nuts in the... so basically what we can do is we can insert the bottom here. We have access to these screws through the holes in the extrusion. But what we need to account for, and this is what the manual is asking us next, is we definitely need to preload some nuts into our extrusion. It tells us basically to preload 2 M2 nuts in the bottom extrusion, although I'm not sure why it's telling us that now and not... Oh, interesting. Wait. We can figure this out. It tells us preload 2 M3 nuts, and it tells us to screw in M3x6 button heads. Now, what I would be interested in right now is, do I need an additional 2 nuts in the center there? And I think the answer, well, actually, how the hell did you figure that? So I guess since they ask us here to insert those M3x6s, they expect us to already have those preloaded with nuts, and then they expect us to preload an additional 2 nuts. Because what's going to go in this location is the Z lead screw, and the mount for that for the Z motor, because that obviously needs to go somewhere, and that's where that will be mounted. So I guess we need to have 2 additional nuts in addition to our already nutted or already nutty screws here. That's nuts. That is absolutely nuts. I don't know why you would do it this way. If you call it out anyways, then maybe call it out everywhere. I mean, sure, it's not Lego, but to be honest, this is more confusing than it needs to be. And you could actually like leave out the nut check, which would simplify your manual, but just suggestions here. I may not know what I'm talking about. We do have a 2MX driver, and we do have access to the underlying screws that we can already like tighten at least a bit, so this doesn't immediately slide around. Oh yeah, cool. We don't need to fully tighten it yet, because, and I wouldn't, because we obviously want to square this completely before we tighten this fully, and for that I would want the top to be mounted as well, which we're asked to preload another 3 on each side. So, and these, by the way, go in the back, which is why we slightly tightened our extrusion there. And I guess now it's about a good time to peel off our tape. I mean, it's pretty clear what's going on right now, right? So we don't need it anymore. 2 and 3. And that printer is just going burr. I mean, look at this. I know the picture is not good and the frame rate is abysmal, but look at this. It's just doing it. It heated up. So yeah, Fysetc kit or not, the printer is the printer, and I guess part of the printer's capability to do its job is not just the vendor you bought it from. There is also the way that you assemble it that's involved, and the care you take, and I think that may actually be the bigger part. So, the manual also mentions here that if we wanted to actually run a Bowden setup, we should preload an additional 2 nuts. On each side. Now, I'm not sure if I ever want to, but since this may or may not end up being an experimental machine here, where we do a few things with, let's actually preload another 2 nuts here. I mean, having options is always good, and I mean this callout is actually pretty good to have. So in case we ever want to run a super light extruder for like sweet benchies. Not sure why I would, because it kind of goes against my belief of not wasting filament. Sorry if I not meaning to insult anyone. It's just my personal approach to this whole hobby, I guess. I would probably not build benchies just for the sake of, or print benchies just for the sake of printing benchies. But it's always good to have a bit of a speed demon around for solving quick things quickly. And you just saw, I mean, this 18-minute print on that 300 Trident actually takes twice as long. And the reason for that is because it is so freaking huge and the bed takes so freaking long to soak and actually come up to temperature, stable temperature on the top side. That is really slow, and that's one reason why I am going to only build small printers from now on. Even if it's a like 120 or even a 1800 or a 180. Actually, what I really want to build is a 180 millimeter Trident. The problem with that obviously is the whole self-sourcing thing, but I think that's a clear oversight in terms of accessible Vorons, because those 250 is a good size. 250, people should build more 250s. They are smaller, they are way quicker to heat up, and 99% of all 3D prints in the world can probably be printed in, or hobbyist 3D prints can probably be printed on a 25. About all the prints I have ever printed can be printed on a 25. The only reason why I went for a 30 is because Fysetc doesn't have a 25. Which, by the way, Fysetc, that sucks. Make sure you add a 25 centimeters cube printer, or 250 cube. And yeah, if you can, add a 180, because I think 180 is about the sweet spot. The Micron has shown that, the Prusa Mini has shown that 90% of all prints you can print on those. Yeah, just, we got our preloads here. Just build smaller printers. They are way more practical. That even goes so far that this printer, we could probably get away with running it from a brick power supply, which means that users who, or like people who build these, would never even have to touch mains wiring. So yeah, this building these larger printers, then having mains wired beds is such a hurdle. It goes so far that you're actually not allowed to do that even in some countries, because of rules and regulations, and I think the barrier to entry should be removed somewhat, and smaller printers that you can actually do run, or that you can actually run on a DC power brick for safety and still get good Voron like results, I think would be the way to go. So I very much like to see those, especially see those in kits. And I imagine, hey LDO, that's probably also way easier when getting those past regulatory bodies. So think about it. Please, please, please think about it. Make it happen if you can. Anyways, that was the mother of all rants. The gist of it is, if you want to build a... by the way, we can flip this around now and then lose our nuts Thank you very much. If you want to build a 350, think about whether you really need that, because the truth of the matter is, even if you want to print something that you would benefit from using a 350 cube printer, or even like a 350 by 350 by 250 like the Trident, even then you can probably just split the model into multiple parts and then acetone weld them. I think that's something you should always consider. All right, so we are currently fastening these. Yeah, build smaller printers, please. And we loosely tightened the screws behind those holes. We can check, we still have 5 nuts each side. That gives us a bit of wiggle room here in case we want to extend the machine or use something like a bow and extruder. Good things all around. Let's move on. Now, extrusions. Nice, finally some extrusions. This is... Now, I remember us having to look at the B and the H extrusions, or the... These are the C extrusions, so 2 holes, no taps in the end. And the H extrusions were, yes, exactly. So what we're looking for here, since we have all taps and since I completely inconsistently labeled those, we in this case need to use something that's labeled C. Because in reality, all our C extrusions are H extrusions, because all of them are tapped. Just saying. Now, it's pretty easy to deduce which way they need to go in, because obviously you need to still have a way of accessing those screws. There's still some packaging left. So we need to, actually we can do this way. And that should do that reasonably well. And do it like that. And I guess the manual will now tell us to loosely tighten these as well. Ooh, they're not part of the final frame assembly. All right, so what we're gonna do now is we are first going to lightly tighten these so we can still wiggle and move them. And then we're going to see how best to clamp these to get this squared. Push comes to shove, we can also use the glass bed of our Trident because that should be big enough to build the whole 3D printer on. There we go. That should at least give it some... Oh, actually... There we go. I'm just closing up the Loctite that was laying here in open form. Let's screw in that one a bit. All right, so we have this. Now, how do we need to do this? We already know that there's wrench access. It's kind of funny with the holes and the wrench access. We're getting treated like kids, and we're getting told over and over again. But for additional nuts, we don't get a heads up. I'm not sure why, but that kind of feels weird. Anyways, what we can do now is for each of these corners, we can clamp those down, I guess, by how do I want to clamp this? I think I want to clamp it this way. Push it all the way in the corner. So I know that I have a square here. Here's the square then. And then I want to use my second block. Actually, I should have done this the other way around. We'll figure it out. We'll figure it out. Obviously, the quicker way would be to just use the glass bed of the trident. That's not in use anyways at the moment. But we can just as well do it this way. Clamp that down. What we need to make sure of though is that we only clamp down one extrusion and not both, because obviously we want the other one to move still. And also obviously I didn't do that, so I get to do it again. There. That's better. So now we have a registering surface here. We can look at whether our wrench access is still valid. There you go. And now we actually need to loosen this again to make room here. Use a second block. And push this up against one of the extrusions. I think I want to do this from the back side and there. And obviously that slides out really, really easily. So now we register it against that. And actually we can also, assuming that these extrusions are square, we can actually register it against this surface here, against the bottom. And the looselessness of the other extrusions helps us with that. So I like that. I like that. Yeah, that looks good, because now I can press the extrusion against one of them and tighten it against the other. Nice. Pretty sure that's square. And very obviously we will need to undo that. That's kind of unfortunate because that went pretty well. I'd say let's do the other one next. So let me remember how we did this. We take this one, clamp that with the one extrusion. So we have a registering surface for the other one, and we want to clamp it a bit above. And here is where you get to see why coders are usually not meant for constructing things, because I think I'm not doing that all that well. Although, we're getting there. We're getting there. Block at the bottom. There we go. Move that. Do not fall out. Please do not fall out. Yeah, whatever. That's fine. We can now, again, press the extrusion down, register it against both surfaces. There we go. And no, while I do have access to the glass bed of the Trident, I don't have access to a granite surface. I think you can overdo things. The the 832 blocks, no, what was it? 531 blocks are doing just fine. Although, I just lost my nuts, so give me a sec here. Yeah, this is definitely a downside to having a standing desk, because anything that falls down has a higher amount of kinetic energy. So it goes faster and it goes everywhere. I found 3 of them. 2 are still somewhere in the carpet, I guess. No matter, we're just gonna continue this. We're just gonna move on. I can pick those up after this stream. I really want to get to a point where I actually have a 3D printer looking 3D printer here, and I'm getting squirreled. So, not sure what to think about that. It's all my fault. I definitely see that. But so let's just fasten those with me, because they seem to be moving otherwise. The surface of this square I am not happy with. I think that came out a bit too low. I'm just gonna redo that, because obviously it needs to be perfect. And yeah, there's other people like Steve and co who are probably way better at building this stuff than me. Maybe you find value in this in this anyways. Please let me know in the comments, really. I would be stoked to hear your feedback. There we go. Got that clamped again. Yeah, that's better. That's how we want it. So that's this side. Let's quickly do the other one. Registering surface there. I mean, once I figured out how it does, how it goes, it's pretty easy to do. Just a matter of gaining the experience, I guess. And whoa! That's probably true for any single thing, which is why I actually enjoy building things now, even though I, to be honest, for the better part of my life, build software more than anything else. Because software was inside my comfort zone. There you go. And I guess, I mean, at least at the speed I am doing this, you can probably follow along pretty well, while I can see people struggling to keep up with the build speed of someone like, let's say, Nero or Steve. So, yeah. And maybe somebody enjoys me struggling here. I don't mind that. I don't mind being your entertainment, no matter what kind of entertainment you derive from me. Streaming these builds. It's all good. It's all good. There we go, that's flat. That's good as well. So, just to reiterate, if you don't have a granite table, block from the side, clamp that down, make sure it's a bit off the ground, so you actually have room to move with the lower extrusion here. Right, so if I turn this around to the point where I potentially lose my nuts again, let's maybe quickly fix that. Block on here, you can see it's slightly off. You don't want it to be too far off because you would still want to register the side surface against the flat surface of the block. Then clamp that down. Then you can put this on the other block, push down, push against this block for both the extrusions, and you should get a pretty square connection. That's obviously assuming that the cuts are square as well. If your cuts aren't square, then you're pretty much screwed either way though. Let's quickly check if we lost any more nuts. And yes, we did. Dang it! I guess the vacuum cleaner will find those now. It's kind of hard to hear with the music in my ear. I hope at least you're enjoying that, if you're ever going to watch this. There we go. Let me see if I can quickly round up some nuts, so we don't leave all of them on the ground. 1, 2 on this side, and I'm gonna dive under the table real quick. The good thing is that these seem to be at least silver, not necessarily stainless. So at least they will be easier to find with some light. There we go. I guess we're at about 4 more missing somewhere in the ground, but I will find those later. That should be fine. And that took ages as well, so. All right, so we have our square now. Yeah, we did that. And we're supposed to have 58 millimeters left and right. We can totally do this. I'm gonna be so happy once those frickin' extrusions are in place. Just to, well, yes, to the dot. This is what we like to see. All right, all right. Yeah, you're not going anywhere. They tried to escape again. They are nuts. They are completely nuts. Now the way you can do this is you can either use this side and try to, as best as possible, align it with the end here, move your extrusion, or like here's a crazy thought, you can also probably add another 15 millimeters or the width of your extrusion to this, and then use this. So let's quickly look at how how exact these are. Well, so if we, instead of using 58 millimeters, use 73, we should be good. And obviously it's not going to be to the millimeter, but I kind of expect those extrusions to be at least somewhat consistent in width, top to bottom, and the remaining error should not make that much of a difference. So yeah, this should do. Now the interesting part here is that we obviously also want these to then be square, so we can't actually fully tighten those. How are we best going to do this? I mean, the way to doing this would be to have it stand up, and if we stand it up on a block, that would actually already be square. So let's just do that. There we go. All right, we can stand that up. Now we have a flat resting surface down at the bottom. We can measure our... Ooh. Those nuts are trying to escape again. They really don't like it here. And we can do the same at the top. Now, interestingly enough, this extrusion slightly protrudes past the top and does not fully register with the bottom. I don't like that. I really don't like that. Also, found another nut. So I guess we're only 3 short. Let's see if we can get the other side to align better, to at least get one nail down before we fill around some more here. And I will need to move this to the front here, because it's all trying to escape. It is all trying to get away. Not sure why. I haven't done anything to it yet. Okay, that's... I should actually be able to now just loosen these again. This is going to go so wrong. All right, at least from a feel perspective, this now feels very square. We're going to measure this in a second to see what we're actually working with. Nope, there's still a bit more to do here. And obviously, I am an idiot. Because what I should have done, obviously, is this. So let's check this again. Yeah, that's fine. That's fine. That's fine. And that's fine as well. Now, the final way we need to check this is by also checking the distance between these, just to see if it's roughly the same at the top and the bottom. So we could also check this against the CAD, but that seems to be about 84 millimeters. And I actually want to measure this from the other side. No, this is... How the hell? I am going nuts here with those nuts escaping again. But we can at least verify if the approach works. So that's 8415. This is 84, so 0.15 of a difference. Not liking that, to be frank. So I guess we need to do this another way. But first, we're gonna loosen that one. So we can, again, for the umpteenth time, add frickin' nuts to this extrusion. I guess having a granite table would be better here, because you can just rely on a few things being square without having to dick around with the 1, 2, 3 blocks. Or the equivalent, the metric equivalent here. Blech. Right, so let's do this again. And by the way, we should probably do it this way rather. Let's see if that goes better. Damn. Don't like that. Let's move that up here. No, actually, we shouldn't do it this way. We should really try to yeah, that's good. There we go. Damn, this is hard. What did we say in the beginning about overdoing squaring? Still don't like that. I still don't like that. I should actually be able to clamp it that way though. There we go. And that way, now I only need to worry about one, which should always be the deal and the goal. And I also only need to worry about one of the sides because the other one will be square as well if this one ends up being square. Yeah, that should do it. That's cool. There's barely any lip between these. So that's actually what we want. Let's check our nuts. Thank you. We're figuring it out. We're figuring it out. Now, what I really want to do is figure out where the inconsistency between the two sides came from. Let's first check if we still have it. So $17. I don't like that. It's almost a millimeter. Where's that coming from? There's a bit. Bit too far in. No, let's. 0.1 of a millimeter. I guess that's fine. Well, no, actually, I want it perfect. Making all these speeches about you being able to overdo it, but when it comes time to pull the ripcord, I don't. The question is which one's out, and that to answer that, the only thing we can do is how would I measure that? Actually, this way. Interesting. So these are pretty much perfect, while these .245. Yeah, we need to redo this one real quick to square that up. That actually worked pretty well, to be honest. We want millimeters. Now that I know how to do it, but obviously if somebody was here to tell me how it's done, that would have been even easier. That would have been probably faster as well, because I'm stumbling through this. I haven't built 50 Vorons before, so let's inspect it again. Let's see how much worse we made it, because that's usually what happens. I achieve a result that I should be happy with, and then I'm not. And then it takes me a couple of tries to actually make it better. And I guess 0.1 millimeter would have been the thing. Fysetc 6. Ooh. Yep. 0.05. That's good enough. And we have, woohoo! Nice. Yeah. This needs to be good enough. And to be honest, it feels pretty good. If I put a block here, it is square. It is square. The rest will need to be accounted for by the cool. And we have all our nuts. And by the way, I am an idiot because I should not have removed the labeling from the outside extruders. I should not have done that because we will need to put those back into the pool if I understand the manual correctly. Well, let's see. That was definitely dumb. I think Enek needs some attention. Let me. Oh wait, that one. Hey Enek, come here. There we go. Let me turn this around so you actually see Enek, not the spiders. There he is. Let me also. Come here. Yeah. He is just about the best dog. Sitz. Fein. Männchen. Fein. Tanzen. Sitz. Sitz. Rückwärts. Rückwärts. Fein. Männchen. Männchen. Fein. Links rum. Fein. Und rechts rum. Fein. Platz. Fein. Steh. Fein. Platz. Fein. Verneigen. Fein. Steh. Fein. Sitz. Fein. Tanzen. There you go. A little bit of Enek. Let me give him a treat real quick. I got those around the corner. There you go. And also, so what you just heard was the Trident doors with the finished print. Let me show you. There you go. I guess we need to do Heatsets. Might be a quick interruption, with quite a quick interruption there. Although no, we can still do these later. I'm just gonna move on with the build here because, to be honest, I'm not quite satisfied with how fast we are moving. So let me put in the music and then go on. It boggles my mind though, by the way, that nobody has found his or her way or their way into this stream yet. We have just about another hour-ish. I'm kind of hoping we can get somewhere still. Now that I slowly get a hang of how this whole machine and the design language is set up. Yeah, yeah. So that was Enek. Pure border collie, 50% working line. One of the most complicated dogs, I guess, or most difficult to satisfy dogs, especially if you don't have sheep. Don't get one. Don't get one. I was well aware of what he was. I was well aware of what these dogs need in terms of training, and what you just saw is just about nothing for him. And you saw his little face light up as soon as I asked something of him. He knows much more than just that, and maybe at some point we'll show you guys. We can show you quite a few tricks, I guess, but it's a bit difficult to capture. Well, we'll need to see. In the meantime, we need our M3x8s, and we can use another M2. The reason why that's different here is, I think, because there is going to be the Endstop on one side and no Endstop on the other. What I'm not quite sure about is why we couldn't put that in before, though, because access to this hole is just fine. And M2s, M2s, M2s. All those nuts. That's nuts. M2x6. Yeah, if you want to get a dog, if you decide to include a pet of any kind actually in your life, make sure you understand its needs. And make sure that those needs align with what you can provide. To a certain extent, a dog or other animal will adjust to a certain extent, and I can definitely tell you that if I don't do enough with Enek, he does start exhibiting behavior that you do not want to see in your dog, which is why, like I said, I thought I knew everything I needed to keep a dog like that. Maybe not. Definitely not, actually. I can tell you that he drove me nuts quite a few times. Because you, like I said, you need to consider he's an animal. He has, oh, here we go. He has certain requirements. In his case, in terms of more mental than physical exertion. So the best way to describe this is 2 years ago I went on a bike touring trip with him where we did up to 50 kilometers 2 hours a day, and he just did that. He just did that because he is going to go as fast as and as far as I request from him, not as fast and as far as he can actually go. So I need to be careful. I need to train him in that direction. But also, when we arrived at our next campground, he just took it easy for about 2 hours, and then he was looking at me like, can we do something else now? Because just running is actually not something those dogs are majorly exercised with. What they really want, what they really need, is mental exercise, and that's really important to understand. So you can have a small flat, you can have an area where that dog can be quiet most of the time, or needs to be required to be quiet most of the time. You can even take these dogs to work, but at some point during the day you need to make time for them to really exercise them. It's just the way it is. There's no getting around that. If they don't get their training, they will take apart your flat. They will try to find other things like protect you, even from your partner. They will try to do just about everything that you don't want. And this is another thing to realize about border collies specifically, but also about other. I don't want to call them high performance breeds, but the high energy breeds is, or high intelligence. It's. I don't like the phrases. I don't like the phrases at all. But you get my point. It's really important that you don't get a dog just because you like how they look. It's really important that you actually know what you're getting yourself into. Yeah, be aware of the needs of your dog. Is, I guess, the most important message. And with that, all dogs are working animals. Some to a greater extent, some to a lesser extent. But Enek and me, we are actually part of a club that does dog training, dog obedience, IPO, things like that. And when we actually have the time to go there, which doesn't happen all that often nowadays, we sometimes see new people coming there with their dogs, and they tell us about all the problems they have. 3 weeks later, they come there and almost all of it is gone, or at least can be gone. I'm not gonna promise you that just because you join a dog club, you're gonna, or dog obedience club, you're gonna have immediate results. But just because those people request and require that dog to do something, just because they give that dog something to do, their relationship with the dog usually improves tremendously. The way that dog reacts to them, interacts with them, improves tremendously. So that's actually a way to go. If you ask me, if you have a problem dog, if you have any kind of problem with your dog, or even if you don't, make sure that you ask him to do things for you. Give him something to do. This, by the way, goes so far, with Enek at least, that he has a 3/4 almost blind or guide dog training for blind people. So he knows exactly what a trash can is. He knows exactly what where you can sit down. He can show you these things. He can show you where the next traffic light is if you need to cross the street. If you need to cross the street, no matter where, he can show you where the curb is to signal you where you need to step down, where you need to step up. He can do this both sides. He can show you, in general, things you can trip on, things you need to go around on. If you have like an obstacle where he could easily pass through, but you can't, he will not take the easy way where he can pass through. And that's one way I've been dealing with, or I've been accounting for his needs, is by giving him his training, because that means that when we actually go into the street and yeah, go outside, he has something to do. He needs something to do. He needs a job. He needs a task. And by the way, I am freaking stupid, because I should have Loctited these screws. I am an idiot. Yeah, that's good. That is really good. I like that. The main question being, did I actually put this on correctly? And the answer being, probably not, but I may have just gotten lucky. Yeah. I am an idiot. I need to take those out again. I need to use thread locker. And by the way, I should have done this on these as well. Fuck! Yeah. Now we really will, we used thread locker on the rails really well, and then I completely forgot for the other ones. Good thing we're taking out off these outer extrusions. I'm kind of tempted to do the inners again, to be honest. I want those thread locked. Although, may actually not. These being moving parts that probably move way more than the, and they're M2s at that, so they are way more important to use thread locker on than let's grab the thread locker here. And let's just there's already one on there. The thread locker we actually want to apply to the tip. And I have no 3D vision, so ooh, fuck. Actually, that works. That works. All right. Just because it's a mess doesn't mean you can't clean it up. Now, how do you do that with blind joints? Tell me. Put it in the comments. Also, I'm kind of surprised here, to be honest, that this manual still instructs you to use thread locker there. Specifically because the location where you're supposed to use that thread locker is actually really, really close to an ABS printed part. So while it's absolutely no problem for us to use thread locker on this piece, because there's no ABS involved, I'm not sure. Having thread locker on the piece there, it's saying there, is such a good idea. On the other hand, most people use kirigami beds anyways nowadays. So there's probably very, very few people who run into this issue. We could have run into this issue if we built this bed completely stock as well. Alas, we did not. And now I have thread locker on my fingers and on the part that's really close to the rail, so definitely something you don't want either. And yeah, I would love to show you another perspective of this, but sadly, our GoPro lost the connection to OBS. Goes way easier here than here. You can pretty much feel the whole thing bind up. I don't like that. Right, that one. Yes, that's how I deal with that. I'm kind of guessing that, or I'm kind of hoping that these are now $73, $73.10, $73.6, Well, I don't like that much that I can also so this one $73.09, this one It's almost 74. I don't get it. And this then 72, which means that we're racked to one side. Yeah, we're racked to one side now. I don't like that. But at the same time, I like it because it gives me an excuse to Loctite these screws. And I really don't mind that, to be honest. These we don't need anymore. I'd rather do this well than fast, because this will be ultimately the backup printer. So we can at the same time do some work on the Trident. There we go. I think I actually like this way of doing it better, to have the bed on there first, because it also gives us a balance point almost. If we square one side, we can have the bed all the way at the other side, and we have a fixed distance. But let's see how that goes. This is live. This is an experiment. And I am doing this for the first time. So stumbling is part of the experience, I guess. Just remember, if I can do this, you can too. And even more important, if you stumble like I am, then pick yourself back up. Now, I would make a joke about you buying my book for self-improvement, but don't have one of those. All right, so let's do this again. Let's actually put this to $73. Let's push it from this side. Let's push it from this side. Let's move the blue stuff away. Let's push it from this side. And from this side. Now we need to register it against a flat surface. Actually, I want to clamp this down here so it doesn't move. That way I can push against it. So the main question will be, and I guess I would like to have a drum roll here. Did I drop the nuts without me noticing? Because I'm obviously still listening to music. Ha! Ooh. I like this. I like this. And this went so smoothly. This went so good. And we got those screws Locktite now. Thread locked. Ooh. And I actually put on the bed correctly, and we have all the screws. Ha! Ha! Winner! Nice, love it. All right, and I guess that gives us license to move on. This is also the first amendment that I think Fysetc made to the manual. So we'll need to look at that real quick. If we go to the we find the GitHub here, O2R1, and you will see that we have a wiring diagram. That's usually what you can expect from Fysetc. And by the way, cool thing about this, many people praise LDO and others for their finished wiring harness. You get that here too. Although you probably should do something about it being more safe. Nut adapter strips, we only get the information here. Page 36, which, oh, you actually can't see that. I'm dumb. There we go. This being the, you can see the URL there, the Fysetc GitHub repository, the README. You can find the installation guide. They tell us, page 18, the NAT adapter strips. You can like them or not. Component prep on 36. Or 45 now, but 36 is this. And if we take, oh, you need to obviously see the manual. 36 is this. If we look at the attached video, then
take out the heat bed support plate.
we will then, instead of doing the heatset inserts in the chain, just need to find the proper adapter for the chain mount, which looks like this. Looks like this. Right, one flat side, one downside, and one chamfered side, and then we obviously need this, right? And that's actually when we now need to do the heatset inserts. So we're going to go to this. We are going to pull this out real quick. I talked about this thing last stream. If you want to get more information, or if you're interested in it, if you're interested in a good alternative to building your own heatset insert press, Dremel workstation makers usually have those, or at least have a Dremel and would benefit from a workstation, I think. And as you can see, you can just as well mount a soldering iron on that to do your heatset inserts. That may not be the cool thing, because obviously we're trying to print all our tools. But to be honest, this is a very stable solution. It takes very little plastic. It is a multi-use tool, and that in itself should be enough of a reason to consider this at least on par with other heatset insert solutions. And we can actually go to the mobile cam. Although, no, don't do it that way. This workstation is too small. There we go, that's better. Soldering iron, by the way, if you're interested, I don't have this one in the comments because I consider it a piece of garbage for actual soldering. Well, that looked kind of crooked, but it still went in straight. There you go. The soldering iron being an Aten 9380. It's basically my throwaway screw around iron. It has held up very long, but its thermal mass is just not where a soldering iron should be. I'm well aware that most people don't need professional tools, but in my opinion, if you're doing any larger amount of soldering, by the way, there you go. Any larger amount of soldering, consider using a JBC. Those are really good. And by the way, not an affiliate, not sponsored, no nothing. This is all just me. Everything you see here is bought. Everything you see here is genuinely supported by me. And by the way, I need to, yeah, I want to clean this up. Maybe do it in a way that you can see. Because even though we adjusted the distance, we seem to still get some elephant's foot. It's not as bad anymore, but I think I still need to play with that. At least it's consistent, and that's actually pretty important, right? So even if you need to still make adjustments to things. Awesome. Now the question is, what kind of screw do I need to use here? And for that, yeah, they show us the heatset inserts.
M3 brass heatset inserts shot M3x5x4 into the print. Load the WIGO terminal and heat-fed thermal adapter board into the print.
Yeah, that's by the way one of the.
Board with M3x6BHCS.
What was that? M3.
Lock the adapter board with M3x6BHCS.
So that's an M3x6 button head. We had those already. And let me move that away here. Things got a bit messy. Why are things so messy here? Well, because I let it get out of hand, but I don't need that. Oh, I'm so stupid. All right. So we need an M3x6 that goes directly into plastic. This does not look like it needs heat sets. What we need now though is the little adapter board and the Wagos. Wagos are here. The adapter board, and by the way, this is the part where I mean that the wires are too short if you don't use the Wagos. These are this is basically your wire reach plus a bit here, and it's just way too short to not do this. And since I'm not keen on having to completely redo those wires and risking that they break at some point, I guess we're going with their solution for now. I was so hoping that we could at least get to the belts of today. But things keep happening. But at least we got a chain here. Not there, not there. So where in the frickin' hell? Whoa. Let me move this a bit closer. Where in the frickin' hell is our little adapter board? I know it was in an anti-static bag when we looked at it last stream, but it doesn't seem to be there. No, it's not there either. Ha! Found it. Sorry that took a bit longer than I wanted to. There we go. So this thing goes in here. Actually, I want the Wagos in first because they give me a bit more stability here. Awesome, that looks good. And we need to slide this board in here. Tolerances are really tight on that one, partially because I'm still not clear on like how to best print accurate Voron parts, to be honest. Because if I measure and calibrate my printer and my material to the dimensions, so my prints are dimensionally accurate. Let's say by using a 2x2 cube. Then all of a sudden, my parts don't fit well anymore on my Voron. But if I don't, then I get things like this happen. And I feel like this part specifically should have been printed by me at 101% scale, or at least with a 99% shrinkage rate, because it feels way too tight. And this hole is a bit over extruded, so the screw doesn't actually want to go in all that well. This does not seem right. They did say M3, right?
The board into the print. Lock the adapter board with M3X6BHCS.
Yeah. M3 by 6. Yeah, this does not work as well as we need it to. Maybe we can clean it up a bit. I think the best tool for the job is actually back here. Yeah, I can't find it, so we're just gonna use scissors. Isn't that fun? And then we can clean up the back a bit. There we go. That looks way better. Yeah. Ha! There we go. That is in there. That's not coming out. Although, to be honest, if you look at that, I am tempted to take a longer screw and just... Although, well, so here's the thing I don't like about this. This is our thermistor connection, and it's just those, and they're actually hanging. So while I think these JSTs will probably work just fine, I would actually prefer a direct connection, especially since we're not quick connecting and disconnecting that, or doing anything quickly to this bed. It's just the way it is. And
VHCS.
So M3 by 16s. I saw that those they're here. 25s.
Lock the T8 screw nut print with M3X16 VHCS.
We'll have to look at that in a second. First of all, we want to screw in our little wiggle holder. This is the first time I see both colors on this printer, and I can tell you that this much. It's awesome. This is exactly what I wanted in those colors. I mean, why build a 3D printer if it can't be colorful? All right. Nice. I like this. I really like this. So what the hell are they doing now?
Lock the T8 screw nut print with M3.
So I guess we're turning this around. And we need the T8 screw nut print. They said. The question is, where the hell is that? It's that one. Now, let's see here. And I think the way they want us to orient this is if you get a better view here, this is what we're at right now. The Wagos mount pointing upwards. I think it goes in this way with the foot of the print pointing upwards as well. This should actually correspond somewhat to what the manual says. We'll figure it out, but let's have a quick look at the manual and how the manual is orienting this before we lock anything in. And the manual obviously deals with something else first. Oh, come on. Well, what we're going to do is we're just going to assume we're right here. And we're going to use M3 by 16s as well to just screw that print on there. Although, to be honest, I want that a bit cleaner because there are a few issues here and it does exhibit a bit of an elephant's foot. Yeah, that's a bit better. And now we just add our 3x16 that the Fysetc amendment tells us. The question I have now is, by the way, why did they not include this in the CNC part? But I guess it's for giving this part a bit of flex, giving it a bit of wiggle room. So if you have too many rigid parts, something needs to give, and especially with rigid parts, you usually don't want that. So I guess they added this printed part here just to give this assembly a bit of compliance. All right, let's find our way back. We still need the chain mount on the side here.
Remove both ends of the tank thread chain.
Can do. It's another bag we won't need anymore. Oh, and this one doesn't open, so it's going to be fun routing the wires through. That kind of explains why they wanted, why they went with a solution where they have those Wagos, because at the very least you get connectors that are easier to route. Also, something to always consider with your drag chains: the ends matter. One end is resistant against moving more than straight, the other one is not. So check those. And I will probably have a bit of trouble getting these loose because I can never figure. Well, I guess they aren't supposed to go apart, so they may just be a bit resistant to going apart, but or like being separated. But I still always struggle with these. So, ooh, that actually, did I break something? No. Ha! That went really easy. Awesome. Moving on.
Install this end. Put the spare end on the other end.
Say what? Install this and put these.
Install this end. Put the spare end on the other end.
So I guess they mean this end. Let's see if I can show you this a bit better. Let's open here.
Find the printed part and lock the removed head with M3X16 VHCS.
So again, M3 by 16. Button heads. Another 2. And I guess our drag chain will point up. So the assembly should look something like this. I do want to do 2 amendments here. Obviously we were gonna do this way, but I think we should thread lock a couple of things here. Not so much the, well, actually the Wagon ones just as well, as much. But obviously, especially since these are heatset inserts, we can't use thread locker, but we can make those screws wet and wild. Following Nera's suggestion, using nail polish, in this case wet and wild, because that's what screws need to be. We can actually make a bit more sure that these do not come out. And that's what we want, right? We do not want to see those screws anywhere but where they are supposed to be. And wet and wild screws don't sound like a bad idea. If you're good for a bit of juvenile humor. There we go. That is a very good change. Still progressing slowly, but I at least feel somewhat better about it now, because I'm kind of getting the feeling that we're at least getting somewhere. And once my brain has wrapped itself around the need to Loctite things, which by the way I was insanely bad with the Trident. We will hopefully not need to do this again and again. And in the end, I'm here to make the mistakes you don't want to make. So you can build your printer faster and safer. Yeah. And obviously I do want to see you entertained by the fact that you are probably better at building this printer already than me. The ones who haven't tried, they just don't know it yet. Is what I'm guessing, at least. There we go. Now I'm satisfied. Again, for the screws for the drag chain. And then our drag chain needs to go on upwards, I guess. There we go. And I tell you, I like these colors. I really like these colors. They look so good, and this moves so good. Slow but very satisfying. Very satisfying. All right. So where do we need to go next? Oh, maybe we should still see what other messages our friends at Fysetc have for us. Yeah, there we go. That's basically where we're done. They're at the same point in the assembly as the Voron manual. Guess we're good. Guess we are good. And we're out because obviously we don't want to. Obviously we want to follow the Fysetc manual, so let's go back. There we go. And where are we? So what do they tell us now? We use thread locker, we added the bed, we have the chain, we don't need those screws. We actually already did that. Yeah, there you go. We already did that. Nice, so limit switch. We need another nice yellow part. Oh, this color is amazing. And we need a switch. Right, so this goes here, I think. But obviously first we need to find our switch. These are the extruder parts. Bearings. Ooh, we're gonna need those later. Magnets we want to keep far away from our rails so we don't magnetize them. But there are bed screws I see here. We don't need the electronic stuff yet. Belts. Looking forward to needing those. Looking forward to needing that as well. Don't need those, don't need that, don't need that. It's all stuff we don't need. Where is our limit switch? Fans. Oh, look at that. And in typical Fysetc manner, it is already wired. So there you go, LDO. Eat that. No, I'm obviously kidding. And to be honest, at some point I would really like to have a look and have a bit of a contrast and compare between a Fysetc kit and a LDO kit. I guess we all know who should come out of that ahead. The question is by how much, and is it worth the extra money? Because, and this is something I do want to maintain here, is while I do realize that some components here are of lesser quality or had lesser quality standards applied to them even to hit that price point. I don't necessarily think that's a bad thing, because there is a quality level you need and there is a quality level you don't need. And as we saw earlier, even though the rails in my Trident are leave something to be desired in terms of them being actually straight, right, in their actual straightness. The question is, how much do you need? And if Fysetc would actually manage to also improve the general safety of their kit just a tiny bit, and if they would consider using better fans specifically, because those fans just suck, really suck. I think they could go so immensely further, much further with their kits, that companies like LDO might not have an excuse for why they're offering their kits so much more expensive. Well, that obviously then having the flip side that LDO might sell less, and they have been doing quite a bit for the community, so Not sure if it's ultimately fair to put him in that position, but price is accessibility, and more accessible 3D printing helps everyone. Especially if people can manage to build that or to ship kits for that 18 squared or 18 cubed trident. That would be exciting. So, since I don't have a non-electric screwdriver handy now, we're just gonna use an electric one. In this case, it's your cheap China variant. Is it good? No. Does it do the job? Yes. Do I expect anything from it past screwing in a couple screws? Probably not fair. Don't tighten these too much. The only thing you're going to do is crush the switch. Basically, once you're hitting this, once your screw is flush, maybe add a quarter turn at most, at the very most. Yeah. Switch orientation is like this. So this is going to the rails. The extrusion is going to sit here, right? It's if we look at it, it's going to go this way around, and you want your switch to sit on the right side if it is aligned with your rail. It seems no problems whatsoever. We're asked to now add M3x8 BHCS, which means we also can go nuts. And since we're dealing with a part that is 3D printed, we're gonna make those screws wet and wild. There we go. Now we need to get some nuts on there. We're just very lightly screwing these on. Not too much at all. Then we can just push this from the bottom, I hope. Yeah, there we go. Because it's keyed itself, and yeah, that means we need to. So this actually is the perfect chance now to maybe give another, or maybe not. Why do I have that bit in there? Oh, nice. There we go. Funnily enough, this thing in its lowest setting also just about has no torque at all. Otherwise, I kind of like it. And it can actually go very, very high torque if you really need it to. Going to screw down the last rail nut here. Nice. Nice. That's what we want to hear. All right. Our angry Endstop. And I guess it is time to take off these sides. Now we need to remember that those are H extrusions that we mistakenly labeled as C and can use for C extrusions as well. That's going to be really hard. So I'm kind of tempted to label them again, but I won't. Because why? And this took way too long to assemble, but it is what it is. Otherwise, I'm kind of tempted to continue still. 2 M3 nuts on the top. One in the back. There we go. And 2 M3s in the bottom. There we go. Don't spill the wet and wild. We don't want the table to be wet and wild. That would be weird at the very least. Oh. Awesome. This is looking nice. Okay, and 2 in the bottom. Sure. And then just hope that they stay there. Not like the group of 5 that gave us so much trouble. Oh yeah, and now it's finally looking like a printer. One E-extrusion, two E-extrusions, labeled to the outside. Obviously these need to go with the hole to the oh no, this is the wrong one. With the holes in the direction that we can actually screw in the blind joint. And we need our rails up top. Obviously, the same principle applies. And also, here's a funny thought. Here's a very funny thought. How about we Loctite these directly? We actually use actual Loctite. How about that? Because then we don't need to take this shit apart again to do it. Thank you, big brain. Thank you, big brain. Oh, and that's... oh, that works. As long as you don't hit any ABS parts, you can go anywhere you want. Dear Loctite. Or dear thread locker, actually. Because Loctite is one of those companies, one of those things you need to be aware of, we talked about earlier. Another one that is having way too much fun at the moment is obviously Apple. Not sure if you noticed that. As a game developer, I'm kind of a bit tangentially involved, at least. And I think Apple just has way too much fun with the European Union at the moment. I do like me my Apple products, to be very frank. But I am very, very glad that I, in recent days and months, have been exploring Windows products and Microsoft products. And while Microsoft is not in any way better or to be considered any kind of replacement, or that there should any comparison even be made, I am glad that I now have a working alternative. For me personally. So I don't actually need to care about either of these companies and can go with whatever satisfies my needs as a customer. I can actually vote either way. and that gives me a lot of confidence in how those things impact me. So here's a funny twist. Shit. These don't fit. Interesting. Let's do the other screws first. Let's do those first and actually work. Because I already remember us putting in screws in some of these parts and they're gone. So I'd like to get as many of the these rails in place as I can, just to lock things down as much as I can. Yeah. Oh no. 2 of them there. Okay, that's good. Let's check this again. Whoa. 2 nuts in the back on the bottom rail. Yes. 2 nuts in the bottom on the bottom rail. And by the way, dear Voron team, why not do this step by step? Have people put on the bottom extrusions first and only lock the nuts there in place before moving to the top ones, because like why balance, why have to balance this? It makes it unnecessarily hard. You're providing a good manual here, and I get that you don't want to baby people, but there, in my mind at least, there is a difference between babying people and making their lives, I don't want to say intentionally hard, but it complaining here though, while I could go and just fix that manual. So that needs to be said here. It is an open source project, and I could just as well go in there, fix that myself. It's not necessarily their fault. It's not necessarily their responsibility to fix this. Open source and all. But I do still consider it a somewhat fair comment, because if they're doing it, and if they're interested in doing it better next time, that may be something they want to know. Ooh. Away with you. And I'm hoping I don't need any nuts there. I don't think I do. 2 at the bottom, 2 in the back, 2 in the top, 1 in the back. Okay. So this is more and more actually looking like a printer. The problem we have right now is that I think our rails are a tiny bit too far. And let's maybe just tilt this over and look at it. Yeah. Yeah, there. So, if I remember this correctly, and let's measure this. Let's actually measure this. Whoopsies. Easy fix. But why? At some point we must have moved our rail here. That's unfortunate, but no matter. Let's look at how much that's supposed to be in terms of distance. The Y rail being the first one we attempted. And the distance from the end was supposed to be $38. So how did we end up with 35 point something? Whoopsies. Okay, and let's check this real quick. I guess that's better. Nice. Then let's just screw those down. Not that one. There we go. Screw the Endstop again. By the way, that one is not, does not have thread locker applied. So sue me. We don't necessarily need to do that everywhere, especially not on those. I very much doubt that that particular one will shake loose. And even if it should, there will be nowhere for that carriage to go, I guess. Well, actually, there might be, but yeah. Don't think that that particular part needs thread locker applied. There we go. And then we can actually put that in place, which will then allow us to slot in those remaining nuts. Really, and that's I think the easier way, to be honest. I really don't get why you wouldn't just first do these two sides, then slot in the nuts, and then do the others, and let gravity help you by locking those nuts on one side. But hey, again, open source project. People especially a free open source project, right? That's something we already need to distinguish. Just being open source doesn't mean that everybody gets something for free, and we're getting some really amazing designs here for free, right? Obviously the manufacturing then done by companies that want to capitalize on those designs. Yeah, and by the way, sorry if I got really quiet. There is basically nobody to talk to. I could talk to Enek. And obviously I want to get through this build, and damn, I thought I would get through this build without stripping any of these. I am so glad that there's Locktite in there to keep that in place. That was really not hard to strip. That was really not hard. But this rail's gonna be so solid otherwise. I'm not especially worried about it. Especially since we chose to lock down all of these and gain the required stability that way. Okay, so now we need to look at our preloads again. If I remember this correctly, it's 2 at the top, 1 in the back. But let's properly check that. 1 in the back, 2 at the top, exactly. And I guess once we're done with the stream, I will have to go screw searching. Other people do soul searching. And even other people may understand something completely different when they say screw searching, but just a thought here. Yeah, that's fine. That should give us enough room to make this into an actual printer. Okay, all the screws Loctite. We have our rails on here. We could, in theory, take these off, but I don't want to yet because we may need to take off parts of these again during the squaring, and we move on. Um, 3x10s everywhere. Sure. And 3x10s, and 3x6, and 3x16. I wonder why they went M3x10 here. I'm not sure what was used with the Trident. Could be 12s, but yeah. Does this have to be 10s? Well, actually, no, that doesn't have to be. You have an assortment of 12s, I guess you could get away with that. You just need to make sure that your extrusions are tapped deep enough. But yeah, still, though this may be personal preference of the designer. Who knows? The Trident and the V0 obviously being from different designers. So yeah. Whoops. Do not hit printed parts, please. That kind of looks like it's like the tab is somehow crooked. Well, we'll see. We'll see. Now I guess we can turn it this way. There we go. Yeah, but really, if you're thinking about building a 3D printer, I'm always noticing it when I'm doing this. If I can do this, so can you, to be honest. So, nothing to be scared of. But please build a small one. Same goes for everything else you want to do. You want to become a computer programmer? Do that. You want to become a game developer? Go for it. Wouldn't necessarily suggest you do that based on what I know from the industry. But especially if you want to be an indie game developer, oh, sure. There shouldn't be anything holding you back. Because if you want to do it, and if you have the necessary drive to learn other things, and the necessary grit to survive there, you should be good. Oh, look at that. We need H extrusions now, which were our C extrusions, which means that A, we have this thing already aligned perfectly, and B, haha, way. Ah, there. Slightly screw those in. This kind of reminds me of the squareness gun. That gun would be awesome right now. Well, actually it can only take away squares and add squares, but if we modified that a bit, best gun in the world. Not sure what happened to it after Jack Harkness used that in one of my favorite, well actually my absolute favorite Doctor Who episode ever. And by the way, I really don't know what people see in David Tennant. I do think he has some skill in acting, but the best Doctor? Nah, I don't get it. Because the best Doctor, and I think the most underappreciated Doctor should, well, in my opinion, Christopher Eccleston. That guy is really good. That guy has such a range as an actor, and such skill, and especially in that that episode. I'm not sure what it was called, but especially in that episode, he really shows it. Might be something you want to check out if you in any way like sci-fi. By the way, I'm loving what I'm seeing right now. This is actually becoming a little 3D printer. I like it. This is how it's supposed to go. All this fiddly stuff there with the rails, it just, well, next fiddly stuff is gonna be belts. Maybe we do this next week. Maybe we just do that next week. Because we're already running for 5.5 hours. Ooh. Well, at least we got something done. I actually like how we got something done. All right, so they're asking us to check distances here. 37. There we go, that should good. That should do. Yeah, just about. No, not even close. The question is, why is that important right now? Now we're gonna fix it. We're gonna fix it. Come here. I'm stupid. Let's see if we can get this to exactly 37. There we go. Yeah. Are you kidding me? Oh, that one's not even... Oh. And because that one wasn't fixed, we can't actually get to it. So if we do this, let's check it again. Check our registering surfaces to see what we're measuring against. There we go. that would mean, if we're doing that correctly, and that correctly, and the lower ones correctly, we should actually end up with a square. Ooh, we should actually end up with a squared printer. That's good. That has room for improvement. Ooh, I like this. It was so fiddly before, now it's going so fast. Well, ish. What I still don't like is how these don't sit flush here. And that is actually something I need to fix before we do anything else. So actually, it's cleverer to do it this way. Because then we have multiple square surfaces. The only thing we want to do is we want us to have a bit of room for movement. And we don't want to clamp our other rail, because now we can measure this one. Oh, yeah, and push it down. And I can't see shit. There we go. That's better. Do we still have? Yes, we still have 3700. We move this exactly there. We screw it against a flat surface. And I like that. I like that very much. Let's do the same thing for the other side. Loosen that up a bit. Move the block. Give us a bit of room. These small clamps are actually pretty useful. I thought they would be too flimsy. But while I have thought about using the bigger ones, I also have their I think these smaller ones are actually pretty awesome. And no, there is no affiliate link for those. Those are available in Germany for some reason, but not in the US. But I can still link them if you guys are interested. If somebody tells me they want them, they need them, no problem. We can deal with the back extrusions later, squaring those. Problem with this one is we need to loosen that from the other side as well, because it's slightly twisted. Because without loosening that, we're not gonna get that flat. There we go. Nice. That's how we want to see it. All right. The question is, let's do these two. Let's do these two screws. If we're here anyways. Ooh. Nice. Oh. Yeah. This is life. This is how it's supposed to be. We can square those up later, I think. The important things to consider there are yeah, we did that. Now we need to use M3/8 and obviously the corresponding nuts. So here's the thing. Obviously this does not involve printed parts, but I would still not want to use I would still not want to use thread locker on those. So, because we don't know, this is probably nylon, the drag chain. I would guess at least. But I'm still weary of the fact that it could be ABS. Not sure. And I guess just fixating this with some Wet n Wild should do the trick. Anyways, it's not like this is a heavily moving or vibrating part, so I'm not especially worried about that moving anywhere it's not supposed to. That doesn't mean that we can't take at least a bit of care to ensure that it doesn't. The interesting thing is that this is again one of those things we could have done way earlier already, because now it's awkward. We could have done this before adding these extrusions. It would have been way easier to screw on. But it is what it is, to quote another maker. Okay. This is crooked. That cannot be crooked. Now it isn't. There we go. And now exciting things happen. Because now we get to, for the first time in this build, look at our panels in closer detail. Don't think they will be anything special, but I trust that they will be good. And by the way, panels is, for example, something that you are, while these are supposed to be slightly thinner than they're supposed to be. I think somebody said something about 2.5 millimeters. Oh, checked in. 2.5 instead of 3 millimeters. Let's just get rid of that. Let's get those back in the box. And I think this is the part we need, and we want it to go in that way. Let's check them actually. Almost 3 millimeters, 2.96. So sure, there's this foil still on there that's going to be an absolute pain to get off right now. Damn. Thought I had it. Sorry, I'm kind of quiet right now because obviously concentration. And I've already been talking for more than 5 hours without anybody giving a shit, which, sure, I get it. Almost. To be honest, I didn't care much, but there you go. This actually looks really good. This, I have no complaints whatsoever about this. And again, this is probably one of those things that you pay a premium for with LDO kits or Lector or what have you, that you even pay a premium for if you source it separately. Ooh, that. Ooh. What the hell? Well, okay. It's in there now. It said I wanted to go, and it did. Loving this. Yes, 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 I am loving this. Again, most of the quality of your 3D printer. Sure, there can be differences in screw quality, there can be differences in rail quality, there can be differences in just about quality of any part, extrusions, how straight they are. And you can get lucky with kits like LDO, you can get lucky with kits like Fysetc. Ultimately, I think the most important factor, the factor that will decide most about how well your printer is going to print, is how well you build it. There's just no getting around that. It's like with dogs. It's always a you problem. That dog is always going to do exactly what you teach him, or exactly what he learned from you, not exactly what you teach him. And especially with a border collie, they learn the 2 hours a day what you want them to, and the 22 hours a day that you don't take care of them or don't play and train with them, they learn what you don't want them to. Well, actually, they're supposed to sleep 18 hours a day-ish, but who's counting? Minor details. The fact is, the things you train your border collie to do, or your dog to do, are the things he's going to do. The things you don't treat in your dog's behavior as seriously and take care of them early, those will be the things that you will be dealing with for a long time. So don't let your dog do things that you do not want him to do all his life. One of those very special, very important rules. And you can't see shit, so let's move that around a bit. There we go. We're currently preloading things for the final assembly of the frame square, I think. So the thing we need to remember is, okay, we got 3 nuts preloaded there, 4 nuts preloaded on the bottom side for there. We also need to preload 3 nuts on the other side. And we need to preload 3 nuts on the top either side. Two, 3, and the other side. And by the way, and at this point we also need to think about mods we want to do. So considerations would be LEDs, although they go probably on the rail further top. We want to think about a chamber thermistor. I think that should go here. 4, 4, 2, 3, 3. So no, I think we will actually mount that differently. But what we definitely also want is a Nevermore. And we're going to mount this on the right side. The reason why we want to mount our Nevermore on the right side, just to give you an idea here, is because if you look at the Nevermore, it wants to draw in the air from the chamber. So it has to go either this way or this way, right? Either it goes this way or this way. The reason why we want it on this side is because of the power. We want to route power from the back and don't have to route power from the front because that's kind of awkward. So right side it is. So we need to account for 1 extra nut there. There we go. Separate extra nut in there. Cool. No, that can't be right. Yes, that can be right. But then we need to use our good old M3x10s. Those are the 8s. Those are the 10s. And we need 2 of those. Dealing with nuts later. Otherwise, we're gonna go nuts. There we go. That. And by the way, for practicality's sake, I just decided to mount the chamber thermistor 1 rail further up, because otherwise the chamber thermistor would go here, and I'm not gonna take those rails off again. Nah. Push comes to shove, we can even do it without a chamber thermistor. That rail goes there. We're asked to add 4 M3 nuts here in the bottom. These, of course, like all the other 4-offs of nuts, being the skirts. Or in this case, I think 2 are the side skirts, and each, and the other 2 are the display. There we go. Oh. And it is turning into a 3D printer. It is slowly evolving. All right. Yeah, and obviously now, there we go. We basically did all these preloads. Now we're being asked to make sure that we have everything. So 3 in the top, none in the sides. 2 in the top this way, 1 in the top back. 2 in the bottom here, and then 4-offs here. Damn. Let me see if I can show you this. 4-offs here and the other side, as well as 4 in the front there. I hope none of those dropped out right now, because they are really loose. They are really, really loose. Yeah, nut check. I think that succeeded. I hope I didn't miss any. That would be very unfortunate. So again, check 4442 we checked, 33 we checked. That's on the top. The 2 here we checked as well. Left and right 3 we have. Oh, and I have Loctite on my fingers, so let's get rid of that. And let's maybe wipe down the printer here real quick, so we don't distribute that any more than it already has moved. Oh yeah, we even accounted for a 1 nut for the Nevermore. Again, chamber thermistor we will deal with separately in a different fashion, I guess. Maybe we'll skip it all together. And then it's on to the extrusions. Oh, let me see here. So those are supposed to be B's, they are not D's. That's definitely a B. This is a D. And this is a D. And now I need you to, of course, see what I'm doing. We connect our extrusions. Wait. Not so fast. Because these are, I think, directional. One end has screws going in both directions, so this end has a screw or a hole there and there, while this end only has one hole, and we need to definitely make sure that we use the correct end for the 2 joining extrusions and the other end for the 1. There you go. And that is the way we want to do this. Same for this one. There you go. This is looking more and more like a printer. Let's screw that down somewhat. Love it. This taking shape. It is taking shape. What I do want to do right now is actually still square these somewhat, because it gives us a better base for building the rest. And this will actually conclude the stream for today, because it is insanely late and Enek probably wants to go for another walk. But I do want these square, and I want the back square as well. So let's loosen these. And let's make sure that we get these squared before we conclude the stream. That, again, to my not so much surprise anymore, nobody joined. You may as well need to watch this after the fact then, but I would have loved to have you here, to be honest. I'm not liking this way of doing things. I think I need to, yeah, that's gonna work better. Because we want to press the extrusion against the other one as well as the top. That still doesn't work. I could actually, what I could do is clamp that there, and then just make sure that I again only have to deal with one surface myself and the clamps deal with the rest. Let's see what that does. Don't like it. Oh, the screw's pulling the rail down. Yeah, that sucks. Also, the carriage was probably in the way. Let's try this again. Yeah, that's it, ticket. There we go. Gonna do that on the other side as well. And obviously that's too high. There we go. That looks better. Now we can register the other off the top. Now the trick will be also to push the rail as far against this block as possible, and that should result. Let's loosen this real quick here. Let's clamp it down some and push it against this block, tighten it. Perfection. Gonna do that with these as well. Although these will be a bit more challenging, I guess, because we also need to outside. Yeah, outside. That. Now this is the slightly awkward part. Oh, I guess it's a fine. It's a fine. There we go. Pressing all the way. So loosening, pumping these once, pushing all the way against the block. Whoops, should be square. It is, but this extrusion is twisted. Now it ain't. There we go. Like that very much. This. And yes, we're overdoing it with the squaring here. So feel free to not do it this religiously, I guess. Or at least I would guess that this amount of squareness really doesn't add much. But, you know. Oh, wait. I still need to push against the block to actually get this square. And only 4 more corners to go. But yeah, that looks pretty good. The reason, by the way, why I am doing this right now is because I can reasonably assume that this inner part is relatively square, which means that since we already looked at these rails and we noticed that they have barely any difference in length, and we would have sorted them by different lengths for each side. Otherwise, I can assume that if I square this properly and completely, I will get an overall square printer and a very good squareness on the gantry, which is obviously exactly what we're looking for. So putting in a bit of extra effort, putting in a bit of extra attention will likely also result in the things we need to build on top of this to be more square, and that will likely have a minute to no impact at all and on our print results. But hopium. And again, your 3D printer is exactly as good as you have, or your Voron specifically is exactly as good as you have built it. And I want this one to be really freaking good. So it can be my reliable go-to replacement, or like, not replacement, but go-to first machine, basically. I need it to be the machine that I print all the other stuff on. Right, we want to go play around with Dax. We want to maybe at some point play around, or at least see what a tap changer is all about. We want to mod the hell out of the salad fork. We need to rebuild that pick and place machine to some extent, and having a good, small, reliable printer that you just have, that you know you can turn on anytime, and it is going to give you good, reliable prints. It's just worth so much. It's peace of mind, especially since my spare time, this is basically the spare time I get from the startup I'm working with. And obviously the time I get with Enek, which I wouldn't trade for anything. So spare time is rare and is to be valued, and especially when it then comes to my personal projects that I obviously want to at some point finish, even though this channel is dirtling and we're meant to just do things for fun. And I believe that should be what you do in your spare time, right? Do different things, do them for fun. If you then at some point make your like migrate your hobby to your professional work, that's your decision. But I think that journaling describes exactly what I want to do in my spare time. It's actually a term that's rooted in Magic the Gathering. For those of you who know what that is, or still know what that is, that has been my favorite game growing up, and doing a lot of things that don't necessarily advance the game has quite the appeal. That much I can tell you, at least to me. Doing a lot of things, taking insane turns, I really like. And it doesn't necessarily need to have an impact on the game. If it's a cool turn, it's a cool turn. It speaks for itself, obviously, right? And who's gonna argue that? That's like, would be crazy if someone were to actually aim to strictly win at that game. That can't be it. Can't be its purpose. Anyways, point I'm trying to make here is Dirtling has its roots in the Magic the Gathering community for the act of doing things that don't advance the the game at all. And my printer is currently riding on its rails. Nice, and it feels so good. It feels so seamless. It feels so you damn. Yeah, what I want to do in my spare time. Seriously. That doesn't necessarily mean that we need to finish any of those projects. As long as we learn something, as long as we go further, we can do whatever. We can do whatever. I'm not especially ambitious in my spare time. I already have to be in my day job because in a startup you obviously need to seriously push, or otherwise you will have to deal with the consequences very quickly even. Right, that's why you're a startup, and if you don't move, those big companies will eventually take over. The only reason why you're competitive is because they need insane amounts of time to get their pants pulled up and out of the toilet before you actually release a new product. So yeah, that's the fact you need to use, and if you don't, you're done. But yeah, that's a bit of a gloomy thought there. So, and by the way, correct me if I'm wrong here. Well, nobody here to do so. Guess I'm getting off lucky or unlucky, depending on how you want to see this. But if this is all square, that's actually the whole... That's the printer. That's essentially the printer being square. Anything we build on top of this is just fluff. We're going to build a second layer to stabilize the idlers. We are going to there we go. Whoops. I always forget physics. I'm not sure why, but gravity today for some reason doesn't register. It did register with Enek though. Yeah. Awesome. I am so glad we got at least this far. But yeah, I'm pooped. I am seriously done. I need a break. The manual suggests that I take one. Well, yes, we're gonna take a break. We're going to continue this next week, or next weekend, same time, Saturday, 7 p.m. Europe, 6 p.m. UK time. Maybe then we can get at least to belting and all this stuff, and move from there. That means that electronics is still one more stream off, but all right. I can be very happy with this, especially since I think apart from one screw that stripped, from one single screw on a rail, this is, I think, bomb-proof solid. It makes a very good impression. It feels smooth. It feels stable. I think this is shaping up to be very, very nice. Feel free to find fault. Let me know in the comments what I did wrong. I will definitely correct it. Yeah, we'll leave it at that. Very happy with how this turned out. Yeah, if you want to see us live, join us next week. In the meantime, Enek is telling me that he found some trash that he wants to trade against some food, and you can see how he knows that he did that correctly, so let me give him some. And yeah, as soon as I do that, that's it. Join us next week. Really join us next week. We're so looking forward to just having fun and having a few conversations that I don't have with myself and Enek. And yeah, let's see how far we get then. Until then, it was lovely to do this. Thanks for you watching this if you dare afterwards, and thanks for playing.